Jai Hind viewers, welcome to AKGEC Digital School. My name is Pankaj Singh, Faculty of IT Department. Today I am delivering my video lecture on subject cloud computing, and today's topic is big data. So before going to the topic, first of all we understand here what is the definition of data. Data basically is a information in a discrete or in a continuous form. Data may be in a text form, in a number form, or in a image form. So here our concern is related to the cloud computing, in which different data set, or we can say the information of any company or database of any company is maintained at a cloud. So how it is managed and how it is uploaded at a cloud, and how these data are analyzed at the end of the server or at a cloud end. So before going to all these things in detail, we first understand what is big data. As the name defined here, it is a combination of two words, that is big data. Data, as I said earlier, it is the information in a form of discrete or either in a text, and big here represent the bulk collection of data. That is not in KB or MB, that is in a petabyte. So we'll understand the actual hierarchy of the data collections after that. So first we take here the definition of big data. I read here, big data is a term for the collection of data set so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. As we know that if we talk about any company or any organization, it have its own ERP system and local server at which all the detail of our organization is maintained. For example, if we talk about a college, if we take the example of our college, we have a local server at which all the details of the library, inventory, and all the employees maintained. But if we talk about in a form of if there are number of companies, or if we talk about whole in a term of Ghaziabad, if there are, for example, 100 colleges, so how this data is collected and stored on a server, it is a very big task. So to manage all such size or such number of companies' data over one place is a very big challenge for any cloud server provider who manage all these data. So the challenge include capture, caching, storage, search, sharing, transfer, analyze, and visualization of data. These are the different categorization, the challenges which organization or the service provider generally face to store a bulk size of data that it will receive from their different end users, or we can say the companies to which it is collaborated. The trend to large data set is due to additional information derivative from analysis of single large set of related data as compared to separate small set with the same total amount of data, allowing correlation to be found to spot business trend, determine quality of research, prevent diseases, link legal citation, combat crime, and determine real-time road traffic conditions. Actually, storing of data is not a big task, but the main task is how to analyze or how to drive the required information in a real time. That is a major concern. So to overcome this problem, we use the concept big data, in which all these data is analyzed and give output in a term that will be helpful for any business strategy, or for example, if we analyze the traffic data in a real time, we will know how the traffic is running over the road, where is a jam, and that data must be analyzed in a real-time analysis. So here we have some technical terminologies used here in a broad perspective. So if we talk about the ERP or CRM that is generally implemented within an organization, that will lie in this category, that is, or we can say that is the intra data or solely managed by any organization. Maybe possible it will cost more, but it doesn't matter because any organization will keep or expand for their own data. After that, as we explore over the net, what type of data? Advertising, mobile, collaboration, e-commerce, weblog, digital marketing, search marketing, recommendations, etc. After that, the which type of data will come under the category of big data? Wiki blogs, sensors, device, social sentiments, audio, video, log files, and we use GPRS, that also come into a category of big data because it is a very large size of data that is accessed by number of million of users. So to analyze this data for a meaningful information or to extract the information so that it will be helpful for any commercial purpose or for any social welfare purpose, that will give the output to help the users that are connected to the specific applications. Like weather data, that is also a large size data that is managed by the big data. Here we written some size as we mark the arrow, or as we see in a slide, the data may be in a size of GB or MB as we manage within an organization, and the data in a terabyte, that is over the network. And we are here talk about the petabytes data. So now have a look about the size. As we all know aware about the size, but have a brief look about their size. If we talk about bit, what is byte? We know that that is the size of 8 bit. If we talk about KB, that is 1024, or if we talk about in a power of 10, that is 2 to the power 10. If we talk about MB, that is 2 to the power 20. If we talk about MB, that is 2 to the power 20, 2 to the power 30, 2 to the power 40, and that's go up to 2 to the power 50 and so on. So from this slide, it is very too easy understand what size of data we are talking about. So we are talking about petabyte data that is of 2 to the power 50, or we can say that is 1024 terabyte data. So when we manage such large size of data for any analysis purpose, we use different techniques to analyze this data, because the traditional approach for managing the data is not possible to handle such large size of data. Now let's have a look what are the drawback of the traditional database system, as I said earlier, because if we talk about to manage a huge volume of data, it is but obvious it will cost more to manage servers, right? Because the server size to maintain the data of 2 to the power 50 TB, it will require more power consumption and more space, and an expert person who can analyze or manage such type of data, it will cost, and the person in term of manage the data is exceed to the actual outcome of the purpose of the data. These are the basic drawbacks, because as I said first, expense, because in a commercial world, money is a matter for every organization. So expense will very high to manage such type of data. And the major concern is scalability. How to scale such size of data so that the valuable information will drive within a real time. So we required more manpower and more servers to manage such large size of data. And but obvious, if we talk about 2 to the power 50 TB size of data, so it will also consume more time to analyze and manage and to hold such of data. And the major concern is here, as we all know, the basic applications of big data, but the data which are managed is come from different source like sensors. If we talk about, there are different sensors are used in a medical field, from which continuously data is come to the cloud server that is managed, like CC cameras also implemented for a security purpose, either in a organization or at road or for a specific government organization. These are real-time data. So if we talk about the security concern, it must be analyzed within a time bound. If we see any malfunctioning, or we can say any such activity that is not held within a premises, so that will be analyzed within a real-time system. Like social networking, as we know the name of these sites: Facebook, LinkedIn, Twitter, YouTube. As we search a lot of data over there, and how this data is maintained and analyzed, that is also the source of data from where the data is come to the big data. Online shopping websites, Amazon, Flipkart. So these are the basic examples, or we can say applications, from where bulk size of data is arrived at a cloud. Airlines, national climate, hospitality data, network stock exchange. As we know that in a stock exchange, data is changed in a real time. That is very crucial for the customers who are connected with the stock exchange. The deviation in a stock within a second may give the advantage, or we can say profit or loss, to a connected user. So to manage this type of data, the traditional approach is not sufficient to control, analyze, or manage data. To overcome or to manage this such type of data efficiently, big data is introduced. Right? Hopefully it is very clear what is the basic difference between the big data approach and the traditional approach. In traditional approach, data is maintained by the database, either in a Excel or by using some integrated form of ERP that are mostly preferred within a organization or intra-organization. So what are the drawback of storing big data? That will be, so overcome, need the right people and solve the right problem. The cost of the costing, or we can say the persons hired for a specific analysis and securing the data will high. Cost escalate too high. Many source of big data is self-regulation and legal regularization. Here we are discussing the 3V of big data. What are the 3V of big data? These are volume. Second V is variety. And third one is velocity. As we mentioned here, the same slide, that represent the size of data in a petabyte PB. So what are these three? We help in analyze the or to manage this size of data. So what are the volume of data? What is the velocity of data? What are the different variety of data that will help out to manage the or categorize the big data? Let's have a look. If we talk about the volume, these are the statistics which is taken from a research paper that give the graph that represent the variation or represent the volume of data that are presently accessed or used over the network. If we talk about data volume between 2009 to 2020, that is exceed 44 times. I repeat again here. It is a statistics of a research paper in which this research is done or analyze the variation in the size of data volume that are used over the network, that is increased 44 times. So why we need big data? Because the traditional approach is not capable to analyze, store or capture such size of data. It will exceed from 0.8 gigabyte to 35 gigabyte. That is also the two level next of the petabyte. So in a given graph or representation, we can see January 2008 to July 2012. We can easily see the tweet, whereas in 2008 the tweet is nearly about, if we talk about, let's take the example of 2010. These are tweets, 100 means 100 million tweets in a day. But nowadays at a Twitter there are more than 400 million tweets per day. So we can easily understand with these statistics how much data is available over the network, or we can say clouds. The digital universe here grow by 44%, and data storage exceed from 2005 and it will represent here in millions, as we see in a petabyte. So these are the very short, or we can say required statistics that give the overall view about what size of data is available and about the volume. And the source of volume, as we know that Twitter, Google, Facebook, and so on. And the variety, what type of data is available over the clouds? These are the variety. Rational data in a form of tabular, as we maintain the database. If we talk about the data of a bank, that is in a form of tables, transaction, legacy data. Text data, as we search any data over the web. Semi-structured data, XML. Graph data, streaming data, as we see movie and many OTT platform available that give streaming data over the network. A single application can be generated collecting many type of data. So as we see here, the variety of data available over the cloud. In a beginning, if we talk within an organization, that is basically used for maintain the relational data, because not required of, if we talk about to the last one, streaming data is not concern of any organization if we talk before 2010. But right now the images, web data, text data, these are the other variety of data available and required for any organization to maintain. But if any organization maintains such data, it will cost more as compared it will put on a cloud. If we talk about a customer or a user, if we talk in 2000, the user only use phone for calling purpose only. But nowadays, if you talk about 2024, today's scenario, a single user use different source of data or generate different data that may be useful for analysis for any organization. For example, a customer using a banking app, for example, PNB app. User also know social media account. We can say Twitter, Facebook. Almost everybody that are using a smartphone have 2 to 3 social media accounts. Also using OTT platform. So if a single person using such different source, or we can say different app to access the data from the cloud, it also generates some data that may be a useful or analysis for any marketing purpose or for any security purpose for any organization. So to analyze such large size of data of a single user, it may be helpful in different way. For example, the data of a banking app is used for financial calculation, for their shopping data also used, like their standard, their way of purchasing and their living standards, what type of living standard a user is of. That is very useful for any organization to analyze such size of data. Velocity, if we talk about the speed of data, as we know in the beginning, the speed of data, if we talk about in 2G, 3G and so on up to 5G, the speed is enhanced in a very dramatic or in a very fast manner, because if we are not able to access a data within a time domain, if we specifically talking about the real-time data, for example, if we are analyzing our traffic data, that must be analyzed or calculated within a time domain, so that will be helpful to overcome the traffic problem within a required area. As I said many times, the real time or fast data, for example, scientific instrument also generate lot of data when there is any research performed on a instrument. Social media continuously generate lot of data. Mobile devices, sensors, either implemented in a agriculture, either implemented in a transportation or in different kinds, they are continuously generate a bulk data that will be deposited, or we can say collected at a cloud space, and that will be analyzed for the further use. Generally it is known by the 3V, but sometime it is also added with the 4th V, that is veracity. What is it? That is data in doubt, uncertainty due to data inconsistency and incompleteness, unambiguity, latency and model approximation. Now it is a basic in which category big data is categorized. It is generally categorized into a 3 part. First, known as structured data. If we talk about the database of bank or any organization, that come into the category of structured data. Unstructured data, that is available on a web, or we are just using a different social media or e-commerce sites, that will come under the category of unstructured data. And there is a third form of data, that is semi-structured data. So major concern of in big data is how to maintain unstructured and semi-structured data in a very appropriate and defined way, so that it will be used for analysis of data that will helpful for any commercial or social purpose. Here is the classification of big data. As I said in the previous slide, it is structured, semi-structured and unstructured. If we talk about the categorization of data, so most traditional data source is structured, semi-structured, many source of big data, and unstructured generally count as a video and audio. If we say how it is unstructured, because the size and the access mode of such type of data is not well defined, so that are randomly or accessed by the number of users connected with the concerned app or the concerned platform. What are the basic challenges as if we manage a big data? So these are the challenges. Data volume are massive. As I said again and again, the data size increase rapidly day by day because the number of users who are using web services over the network, they are access or generate different type of data. So to manage such size of data is very costly for any organization. And the second concern is the reliability. How can a person rely on the source of the cloud at which data is stored, or from the source it fetch the data for their specific purpose? So that is also a concern, or we can say challenges for a big data. And another that is expected, because if any device have hardware components, there is a possibility of failure. So all kind of failure that may be in a type of disk, hardware or network. So that is also a concern of the user that are using cloud services, that may have fear, or we can say the concern about the disk failure, hard failure or network failure. And the probability of failure simply increase with the number of machines. As we know that it is basic mathematics, if the number of machine increase to store the data, the probability of failure, because they contain the hardware components, will also increase. As we also know, and I discuss in first slide, but I will take here the detailed applications of the big data where it is used for analysis. These are smarter healthcare, homeland security, traffic control, manufacturing, multi-chain sales, telecom, traditional analysis, and search quality. So these are the broad application area where big data is very helpful to analyze large size of data. For example, if we talk about the hospital, they generate lot of data about the their patient, about their diseases, and this data is maintained at a cloud and much helpful for the users who are doing research on such data or manage such data for access the future costing, how to minimize the cost of such diseases and so on. Likewise, we all know that the smart homes are also available. So the sensors which are installed in a home, they are continuously generate the data that is also stored at a cloud. So these are the applications where big data is used. Thank you.